Today at FSW Construction, I'll be speaking about lumber and wood products. First, we'll start with the different kinds of sawing and the kinds of wood planks that you will get depending on which way you're going to take the cut in a piece of raw wood. Plain sawn growth rings, roughly parallel to wider face of the board, is shown at the right. Something you might expect to see maybe on a floorboard, some furniture like this, and then quarter sawn growth. Rings are close to perpendicular to wider surface of the board at the left. And this is something you might see more in a door or maybe perhaps a tabletop. Two good pieces of wood. Here's a picture of them that show a little bit more detail. The plain sawn lumber, the broader grain pattern on the wide face. There's greater distortion during the drying, so you do lose some pieces, more uneven surface erosion or wear, and more effectively sawn from the log, so it's less costly as it's going with the grain. Also called flat sawn or flat grain. On the left is red oak, showing you the varieties of color, and the white oak, two popular types. Quarter sawn lumber is more narrowly spaced grain pattern size on the wide face and less distortion during drying or more even surface erosion or wear. It's more costly to saw from the log. Rift sawn left is the angle of grain that falls between perfectly quarter sawn and plain sawn. Also called edge sawn, edge grain, and vertical grain. We're seeing examples of red oak. Seasoning. How are we going to dry this? After lumber is sawn, it is seasoned, which is dried. It's either in open air or it could be placed into a kiln. Seasoned lumber is lighter, stronger, and stiffer than the green unseasoned lumber. Decaying, causing fungi cannot survive in wood with a moisture content abbreviated as MC below 20%. As wood dries below approximately 30% of MC, it shrinks mostly in the cross section and only slightly in length. The difference between the rates of tangential and radial shrinkage cause distortions in shape, especially in flat sawn lumber. So here we can see where, as it's getting out towards the edge, the radial is actually causing it to lose moisture at a different rate. Wood eventually dries for equilibrium with the surrounding air, and it's reaching its equilibrium moisture content, the EMC. And the EMC for exterior uses is between 15% and 19%. EMC for interior uses is between 5% and 11%. Interesting to note, down south, the 11% average moisture content. Surfacing. Lumber is surfaced to make it smooth and more dimensionally precise. Framing lumber is usually surfaced on 4 sides. It's going to be seen on all 4 sides. Sometimes it'll be covered up, but you need to make it available. The finished lumber may be S4S on surface or surface 2 sides, which is S2S. The other sides to be sawn and surfaced by the woodworker. Surfacing after seasoning is the S-dry. It removes some drying distortions. Surfacing before seasoning is the S-green, GRN. Sometimes more economical, best for a wood species that doesn't distort excessively as they dry. Construction planking, unsurfaced, resulting in a plank that is stronger. No material has been removed and more slip resistant. You can see that framing lumber pieces are graded and stamped for structural strength on this chart. Higher structural grades have fewer defects and when left exposed are generally also more attractive. Grading is the most commonly performed visually by trained inspectors, or it may be done by a machine. What you get is what you pay for. So you can get number one, structural, you're going to pay a higher price point for this grade, structural applications where highest design values are needed in light framing sizes. You can get a light framing typically utilizes the grades of constructions or standard or utility. And finally, the wood stud, an optional all-purpose grade designed primarily for stud uses, meaning it's going to be covered, so its appearance is not the most important aspect, including load-bearing walls. Appearance and grading. Finished lumber is graded for the extent of defects, such as knots and other appearance characteristics. Appearance grading is always performed visually. Here's the example of this chart. There are different grades, B, C, and D. The finished grade, you can do a Superior Prime E, Special Western, Red Cedar, or Pattern grades show different kinds of grading, Clear Heart, A grade, and B grade. The supreme choice of quality, and the grades for the selection number. Structural properties of wood. As you know, we're making wood studs, so wood has both useful tensile and compressive strength. The strength varies significantly with the direction of grain species and the presence of knots or other defects. Defect-free wood is close to the strength of steel on a per weight basis, but typical grades are weaker. Strength also varies with the duration of the load, moisture content, chemical treatments, temperature, size, and the shape of the piece. A quick note about those wood knots. They're very difficult to work with. Sometimes if the saw blade takes them, it might send a bump or send things in a different direction. Unintended consequences, the presence of knots is always something to be avoided if possible. Also, with time, you may lose the inside of the knot, creating a hole. Lumber dimensions fall under an unusual classification. There's the nominal size, the actual size. Actual sizes are less than nominal size because they are actually, as it implies, the actual measurement. So 1x4 is easier to say. That's why we use nominal instead of stopping to say the 3/4 or the 3.5. 2x4 is easier to say than 1 1/2 times 3 1/2 inches. These were all started in the beginning of the process when sawing wood was not terribly accurate, so quick definitions could be given. A 2x10 typically measures 1 1/2 inch by 9 1/4. U.S. lumber is priced by the board foot, based on nominal, not actual dimensions. The 12-inch square and nominal cross section is 1 foot, 1 foot board. An 8-foot 2x12 is the same as a 2x12 divided by 12x8 equals 16 board feet. Our next classification of products, now we're going to add wood products, which are man-made additions to wood fibers by creating a combination either of a synthetic or a plastic or a hardener or a glue to the product to increase its strength. And also you can work with various different pieces, glue them together as one larger piece, and maximize the availability of a lesser quantity of wood than, say, looking for an old growth tree, which can give you a long beam. Let's take a further look. Manufactured wood products. Solid wood and wood fiber materials can be used in the manufacture of various wood products. This creates more sizes and shapes. You can make a specialty shape. There's fewer defects, more consistent quality, more effective use of wood materials, and in some cases, with the added glue. It's stronger and stiffer than solid wood members. The most typical of these is the glue laminated wood, and you've undoubtedly seen this particular kind of wood. You see a whole stack that's been glued and bonded together. These beams are made from glued solid lumber pieces. They're readily available in larger sizes, stronger and stiffer than solid wood. This is a key aspect for the types of housing that is now popular, which is the open space plan. So you get a nice beam made out of this glue laminated wood, takes care of the structural integrity of many smaller pieces of wood columns. Also has a great aspect where it can be curved. It uses high grade pieces efficiently only in the parts of the beam with high stress levels, while using lower grade materials in other areas. Now we get to take a look at the sectional, or at least what they might look like. In order of increasing strength, there's LSL, the laminated strand lumber, and oriented strand lumber, the OSL, glued shredded wood strips at the top right. So you can see these flakes. You can actually more or less examine all the flakes, and you can even see the glue that's kind of been used to keep this combination together. Kind of like matching pulp and then gluing it to make it one unit. Laminated veneer lumber, LVL, is glued full depth veneers, and it's shown resting on its side. So it looks a little bit more typical of the wood features that we might see on the surface, but the interior here also kind of resembles our LSL. Parallel strand lumber, the PSL, are glued veneer strips used in beams, headers, short beams over openings, studs, non-structural rim boards, and etc. A popular interior feature, you have encountered this, and something that's commonly used for flooring, is the wood plastic composites, a new feature on the block. It's made of mixtures of wood fibers and plastics. It may be pre-finished, used for exterior decking, wood trim, etc. It's less stiff and greater thermal expansion and contraction than solid lumber. Also, plastic lumber is greater than 50% plastic, has both finish and structural applications. It's a good something that might deter your termites and other bugs. Structural wood panels. Hurricane building has really gained a lot by strengthening using structural wood panels in their entire plate-like stage. It's plywood, laminated veneers, the composite panels face veneers bonded to a solid core. The oriented strand board, OSB, shown at the right, glued. Shredded strands like LSL, the particle board glued particles smaller than OSB strands, fiberboard glued, and very fine grained wood particles. Structural wood panels. Standard panel sizes, 4 feet by 8, 5/16 to 1 1/8 inch thick. Used as sheathing on framed walls and roofs, and subflooring over floor framing. Span rating example. A 32/16 may be used as roof sheathing over rafters spaced at 32 inches or as subflooring over joists spaced at 16 inches. Very strong. Exposure durability classification, exterior glue, the best veneers for permanent exterior siding. Exposure 1 and exterior glue, best veneers for permanent exterior siding. The Exposure 1 exterior glue, medium quality veneers for interior use with prolonged exposure during construction is most common. and exposure to for interior use, minimum wetting during construction. Okay, here's something you see quite often when you're at Home Depot. You can see wood that has this particular certificate that's attached to it, most likely printed onto the wood itself, the APA mark of quality, the structural wood panels, which the plywood veneer grades A through D, each labeled. Lower grades are less smooth and have more defects, such as knot holes, for example. A CDX C and D faces with exterior glue for exterior sheathing, C-plugged D floorings underlayment. C-plug face provides an especially smooth surface between the carpet and resilient flooring materials. This is the typical printed manufacturing notification. It's especially designed for subflooring and wall and roof sheathing. Panel products are also used in a variety of non-structural applications, such as finished paneling and cabinet work. We need to treat our wood, and many factors come into making the wood safe for prolonged periods of time, especially due to the environment or any other attacks that it may have. Fire retardant treated wood, chemical salts, pressure impregnated into the wood to reduce its combustibility. This may be due to codes. If you're looking to beef up your code review, you can use specialty woods to help you reach that 1 to 2 to 3 hour applications that you must meet. The limited application it's used where building code restricts the use of combustible materials. There's preservative treated wood, sometimes green wood. You'll see a wood that may be green, not necessarily green in that it's fresh, but it may be cover coated. It protects the wood from decay or insect attack. And especially here in Florida, wood exposure to the weather and contact with the ground or areas of high termite risk. Especially on your sill plate, it's a good use for it. And also on your decks. Wood preservative treatments. Pressure impregnated waterborne salts are the most common. And you see these little tack marks in here where it's actually injected more into the bottom cells and it floods into this first strata of cells. CCA contains arsenic, common in the past but has become highly restricted because of its toxicity. Things used are ACQ, CBA, CA. High concentration of copper, which kills fungi. Most common require corrosion-resistant fasteners and hardware. The SBX and other borate compounds, they are non-corrosive, non-toxic, and primarily for insect resistance, not for exterior exposure or ground contact. So the more chemical and the harder the element is used, the more it's going to contain stronger elements that touch the ground. Let's talk about wood fasteners. We need to find a way to adhere these nice pieces of wood we're going to use onto the structure and with each other. We come across a very old product, which is the nail. It's inexpensive, fast, and easy to install. They come in a variety of sizes, sized in pennies, 16D 3½ inch and 8D 2½ inch and 2D. Different kinds of types. We see the common nail, box nail mostly used, and then a casing nail, finish nail, the brad, the whole thing's together, deformed shank, and then you can see that this little ridge helps it adhere to its whatever it's being hammered into. A hardened concrete nail can fasten into concrete, and these ridges help to deploy it. Here's an old-fashioned cut nail and a roofing nail, which has that high tack braid and also has the braid on this end and also a flat piece to help disperse its head length over any kind of fabric that it might be covering. Materials, they can be bright, plain steel. It's a good use is galvanized, zinc coated for corrosion resistance is really a good investment. It can be stainless steel, it can be aluminum, and in some cases copper. Many shapes for different uses, and they may be driven by hand or preferably with a nail gun. Screws and bolts. Greater holding power than nails, more expensive and time consuming to install. Bolts require pre-drilled holes. Some screws require pilot holes, and some are self-drilling. The greater variety of shapes, sizes, head styles, and driver shapes. You can see the oval head, round head, flat head, so that will fit in and become one with the surface. This will protrude above it. Then we have the hex head, Phillips head, most common, but a very good fastener for maintenance use and a quick fix. And then finally bolts, which are used to hold together larger pieces of wood. We have our famous plates, the tooth plates, metal connectors. Different versions of this are available that help with increasing our hurricane wind resistance. There's metal frame devices in the middle, different anchors different configurations for different needs to match two different pieces of wood in different ways of doing it. So a typical foundation might have this bracket and more brackets and straps. Also adhesives and different kind of joints. Manufactured wood products. What can you come out? What's the complete thing that you can buy a whole assembly? And one of those things would be a truss. Light wood members, 2x4s and 2x6 are joined with the tooth plates we just saw a few seconds ago. Right, there's the plates keeping it together. These increase the long span capacity. Just like that heavy header that was made by 5 pieces of lumber stacked together that was very beefy. This is the alternative to that, which is using your truss formation, dispersing weight through an excellent means of geometric configuration. The triangle being one of the hardest things in structural stability. There's a long span capability, rapidly erected on site using light-duty cranes. You can ship it into the work site on a flatbed, and it does make congested attic space because you'd have to work your way through there. So you do have to keep track of what your mechanicals, if there are going to be some put in the space, and how it's going to fit. The famous I-joist, and you can see it side profile when it gets its name, can span further than solid lumber using less raw material. Top and bottom flanges of solid lumber or composite material, LVL here. Webs of OSB or plywood, and you have to be careful if you're going to drill into the integrity of this particular beam. Panel composites can act structurally or be attached to a structural frame. So here's our stud wood frame. If we attach our LVL to it, we increase its strength. Even more increased strength, we can sandwich it with another board on the other side. And the structural, and then we can also flip this whole scheme, skip the studs, put some styrofoam or some kind of insulation material, and just live off the integrity of these two boards that sandwich the insulation between it, which is pretty nifty. This is used in California. Factory-built housing, manufactured homes built on a towable chassis to U.S. HUD standards. Modular construction to local building code requirements, but the factory-built and trucked to the construction site. So this is a handy solution. This is the future because we can make the house and structure within the confines of a factory environment, meaning all the connections are well thought out, and in this kind of condition, you can really work on the details. But again, expensive because you do have to haul it, you do have to lift it into place. And it's also a trained crew that has to work with it both in the factory and in the insulation. This is the end of this slideshow. If any questions, let me know. I'll leave you with this nice construction. It's the Arkansas Crown Chapel. It kind of really evokes the feeling of wood. It has glass enclosure, but you couldn't tell. And it does open for weddings, and what a nice space to admire.